Good day, my people. Welcome back to my YouTube channel. Today we're gonna focus on engineering science, guys. I know you've been waiting for engineering science video, but guys, now I want us to do hydraulics. This hydraulics chapter, guys. Hydraulics chapter mostly start from N3, it goes to N4. So without waste of time, guys, I'm saying this video is for N4 and N3 students. Okay, now if we talk of hydraulics, guys, let's first by saying what is an hydraulic system. I want us to discuss what is an hydraulic system. Um, Hydraulic system, we say, it uses pre pressurized fluid. It uses a pressurized fluid to transmit or to transfer force between points. Okay, we say in a hydraulic system it uses a pressurized fluid to to transfer force between 2 points. So what are we talking about here? We simply say in a hydraulic system. Example. Let me give you an example of where do we apply our hydraulic system. Um, an example where you can apply on a hydraulic system mostly we found it in heavy machineries. For example, excavators, TLB, forklifts, and etc. Right? So here, the most important thing. Let's talk of um, to say factors in functioning of hydraulics. What are the factors in functioning of hydraulics? We say we have a pressure and area, of which pressure equals to force over area. So in this case, pressure is inversely proportional to the area. Okay, yes. But the most thing that we have to learn about here, we are going to learn about two things. Number one, a hydraulic jack or hydraulic press. Okay, now on a hydraulic jack, let me let me sorry about that. Let me first draw it here. Okay, um let me redraw it nicely. Okay, we have a cylinder here. Over here we have a load. Okay, we have a handle over here. All right, now with the drawing that I've drawn here, we can just simply say it's an hydraulic jack or you can say it's an hydraulic press. So simply meaning we are gonna apply an effort here. Then the moment you pump, where this type of a jack is like an hydraulic jack used in a vehicle. If we are pumping on this side, we are trying to lift up the load on the other side. Okay, so now we have to separate it, and now we say this side is plunger and the other side is the ram. Okay, now we say we know pressure. Let me write it this side. Pressure on the plunger equals to pressure on the on the rim, meaning that we know pressure is force over area. So on this side, we have a force over here acting going down. And then this side, we have a force of which is our W. W is what? Is weight. So we mean simply say is force over small letter area, because we have a smaller diameter this side, equals to W over A. Take it further, F over pi d squared over 4 equals to, what is W? Is mass times gravity divided by pi capital letter D squared over 4. Remember, this side we're going to have the diameter of the rim. This side, the small letter D here, the bigger diameter D there. The diameter of what? Of the rim. Simply mean the diameter is this thing. Remember, these two things are cylinders. Are we clear? But these two cylinders on the other side, we have a plunger, the other side, we have a rim. So simply meaning here we can say force over d squared equals to mass times gravity divided by what? By d squared. So why are we saying this? Because force on the plunger equals to the force on the area. Now the next thing we say volume displaced by the plunger equals to volume displaced by the ram. Okay, if we talk of a volume, we talk of the liquid that was displaced. So meaning the liquid that is what is being transferred from that one point to another point. Now we know that if we are pumping here, we are pumping certain strokes, right? We are pumping over here. So we are pumping certain strokes. So if we are pumping here, we simply pressurizing the liquid that is inside the system to lift up the load there. So that's why we say the volume displaced by the plunger equals to the volume displaced by the ram. But now we know area of the plunger times stroke length times number of pumping strokes equals to area of the ram multiplied by the height it will move. What are we talking of, guys? If it moves from here going downward here, you call it stroke length. Okay. Now, if our load it moves from here, it goes up there, is the height at which it moves at. Are we guys clear? So, meaning area is pi d squared over 4 multiplied by the stroke length multiplied by number of pumping strokes equals to pi d squared over 4 multiplied by height. Now we have a pi this side, we have another pi there, so 1 over 4, 1 over 4. So we have a d squared multiplied by stroke length multiplied by number of pumping strokes equals to d squared multiplied by h, of which is the height at which our load will move at. Okay, now we are left with the last part. The last part of which we say is MA. MA is mechanical advantage. We say mechanical advantage equals to force over effort. But meanwhile, we know an effort is a force. So which force are we talking of? We have a force over here. So meaning now the force that we are pumping at there, we call it a what? An effort. So now meaning mechanical advantage equals to force over an effort, of which here is an effort. So meaning here there's a mechanical advantage, of which it makes the conversion from effort to the force that we are applying at. Okay, so all these formulas that you see over here, we're gonna use it all regarding the question of hydraulic jack and the press. Hope you guys do understand that one. So before we can move to the next one, guys, of which we say is hydraulic pump. Hydraulic pump. So guys, just know that on this chapter we on N4 engineering science, we're gonna focus on hydraulic jack or press or the hydraulic pump. Hope we are clear on that one. Okay, so on an hydraulic pump, let's So simply mean if we have a dam here, just say if we have a dam here, we are maybe gonna have a pump maybe here transferring liquid maybe to another dam over here. Okay, I will just write the formula here. We say Q equals to V over T. Q is the flow in meters cube per second. C is time in seconds. Then the last one is V is volume in meters cubed. So now what you have to remember again, the last part is that 1 meter cubed, sorry, 1 meter cube equals to 1,000 liters. Are we clear? And now we know 1 liter equals to 1 kg. Okay, so meaning now if they ask you to calculate the flow, the liquid that which it flows at, we say Q equals to V over T. Then you can, that's when you can start applying formulas there. Now, and also if they ask you to calculate the volume, displaced, we can also say, allow me to write it here. I know I can see I don't have a space. V equals to area times stroke length times C times N. Okay, whereby A is the area, volume equals to A multiplied by stroke length, but what about C is the number of cylinders we have, and N is the number of pumping strokes. Hope you guys do understand on that one. You say C is the number of cylinders we have, and then N is the number of pumping strokes, and A is the area of our cylinder. Now, hope you guys do understand. Here we're gonna apply the same knowledge that we've learned about here when you're going to answer a lot of questions, guys. So on our next video, guys, we are going to treat some of the previous question papers. Thank you guys for watching my YouTube. Thanks you guys for watching my YouTube videos. Please like, share, and subscribe. I thank you.